When you conduct statistical analysis, the knowledge about data type is very important because many statistical methods and tests were designed for a specific data type. However, there is a lot of confusion regarding data type because many different terms are used, and when you look into statistical textbooks, you will likely find different terms for the same type of data. So here's an overview. In principle, we have two groups of data, metric and non-metric. Metric data are measurements such as 27.3 centimeters, 14.5 degrees Celsius, or 70 kilograms. Also counts are metric data. For example, when you count the number of plants per area or eggs in the nest of birds. There is, however, a small difference between egg numbers and, for example, weight. The number of eggs is a discontinuous or a discrete variable because a bird won't have 1.7 eggs in the nest, but only 1, 2, or 3. In contrast, weight is not discrete because it can be any real number. For example, 69.7 kilograms or 71.3 kilograms. The difference between continuous and discontinuous variables is, however, not extremely important, since most statistical methods for metric data can deal with both continuous and discontinuous variables. More important is the difference between metric and non-metric data, because non-metric data are very different from metric data. When you have non-metric data, you count how often an observation is made. For example, you count how many patients have recovered or how many have not. Or you count the number of people with or without a bachelor degree, or the number of smokers versus non-smokers. What you measure for each person is the category to which she or he belongs to. For example, smoker or non-smoker. Let's see an example to illustrate the difference to metric data. On the left, we have metric data. These are weights of individuals. In each individual, we measure the real number. On the right, we have non-metric data. In each individual, we only observed the attribute of this individual, the category it belongs to. It's a smoker or a non-smoker. Now, when we summarize such data, you will also see that metric and non-metric data are summarized differently. Metric data can be summarized using the mean, which describes the typical value, and the standard deviation, which describes the variability of individual measurements. Finally, we should add the sample size to show how robust our data is. This way of summarizing data is meant for normally distributed data only. Non-metric data can be summarized by the sample size and the incidence with which an attribute was observed. There is no point in providing a mean value or a standard deviation. So now it's clear that non-metric data are conceptually different from metric data. So what about the difference between nominal and ordinal data? Nominal data accounts of characteristics or attributes that have no particular order, such as colors, blue, green, red, or gender, male and female. Also, the attributes smoker versus non-smoker are nominal data. Here, nominal means that we have classes with a name, which is the meaning of nominal data. Ordinal data are data with a hierarchy, such as small, medium, large, or the degrees, bachelor, master, PhD. So what is an easy way to determine what kind of data we have? It's quite simple. You only have to ask yourself, what did I measure in each subject? What were my raw data? When the answer is a number, then you have metric data. If the answer is a characteristic or an attribute, such as red, green, blue, small, medium, large, or dead and alive, then you have non-metric data. When presenting the findings of a study, people often don't show the original data that were measured, but they create so-called derived data. Derived data can be percentages, rates, ratios, indices, and other types of data. Derived data have some advantages, but also some drawbacks. For example, often data type changes, but that will be discussed in the next video. So this is all there is to know about data type. Sometimes people want to add a data type called binary data. For example, true and false, or female and male. However, binary data is in principle nominal data, so there is not really a need to add complexity into this classification scheme. Some people also prefer to structure data types using this classification scheme. Here, metric data are called measurement variables, rank data are ordinal data, and attributes are nominal data. To conclude, whenever you are uncertain about data type, just ask the following question: what did I measure in each individual?